This is our wet test area. It's here where we bring our systems, our complete systems, and install them in such a way that we can test them dynamically, exactly as though they were in operation in the field. We run them with water, we then test for leaks, we then do all the calibration and testing required to ensure that this system will be fully functional and ready to go out of the box when it arrives at your site. This is our C256 automated control system. Let's go ahead and power it up so we can show you how it works. Upon power up, the system goes through a startup routine. You can see the numbers here are beginning to straighten out. This system here is the ambient ozone gas detector. It goes through a 5-minute warm-up routine in order to test its systems. Initially, upon startup, we see a very high reading here. This reading will stabilize to 0.00 parts per million. In the wet test area, we do a calibration where we verify that it indeed shows 0 when we have 0 ozone. Once we have zeroed the sensor, and it usually takes about 2 hours when we're starting up a new system, we're then ready to go on to the next step. The next step would be filling the system with water. And we have to fill the system with water because we cannot start the pump without the water level being high enough to allow the pump to start. So we would then start the pump by turning this on, and we don't have any water in the system now, so the pump didn't start. But upon the pump starting, that then enables the ozone generator. While the C256 controller is going through its warm-up routine, we're going to go ahead and move up to the ozone generator and demonstrate the startup procedure for it. The power switch has already been switched on, but nothing happened until we turn the pump on. Once the pump turns on, the ozone generator is now enabled. The ozone generator starts up. Upon starting up, the next thing we need to do is open up the regulator until we see 30 to 35 psi of compressed air on the air supply side. It's at that point we're now ready to make oxygen and set the oxygen flow with our oxygen flow meter. The system will have come with the needle valve on the bottom closed. So what we will do is we will open the needle valve, and upon doing so, we can then set the oxygen to the required flow. On this particular device, it is 40 standard cubic feet per hour, which is equal to about 20 liters per minute. As we open this up to the required flow rate, we will notice the reactor pressure gauge is still at 0. And the reason for that is now that the pump is running and now that our injector is drawing suction, it's drawing a vacuum on the system in such a way that the oxygen flow that we're delivering at the required rate is being delivered under vacuum, which of course prevents this from showing positive pressure. Now, because the reactor is designed to run at maximum performance at a back pressure of approximately 3 to 9 psi, we then use the back pressure valve on the bottom along with this flow control valve to adjust them simultaneously until we get 40 here and approximately 6 here. It's at that point the ozone generator is up and running and ready to go. Now that the ozone generator is running, the feed gas flow is set properly, the reactor pressure gauge is set properly, we now have the ability right here locally to give an ozone command by simply rotating this knob from 0 to 100%. Upon doing so, we will be then introducing ozone into the water. What we're going to do now, though, is shift ozone control from local to automatic, and we'll do so by switching this switch from local to automatic. Now that the ozone generator has been set up, we're going to move back down to the controller system. We now see that the controller system has stabilized. The ozone concentration has stabilized at 0 since we're not yet producing ozone. And we can also see that the ambient detector is stabilized at 0, and the alarm lights have stopped flashing after the 5-minute period it takes for the system to stabilize. It's at this point we're ready to start generating ozone. And the way we do that is by entering a set point into the process controller here. Let's say, for example, we're doing bottled water and we want 0.3 parts per million to exit the skid to be sent to our process. We will then enter 0.3 parts per million using the up key here. We have two keys, an up key and a down key, and we'll simply adjust that until we're at 3 parts per million. It's at this point that the controller will now take over control of the ozone generator. When the upper value, which is the process variable, which is equal to the reading here, is below the set point, the process controller will ask the ozone to produce more ozone. The process variable will then begin to rise as more ozone is introduced into the ozone contact tank. Eventually we'll reach a point where this value is equal to this value. It may exceed it slightly. If this value exceeds the set point, then the controller will bring the ozone output down a little bit. Eventually, these two will come into agreement, and is at that point the system is stable. As the process calls for more water or less water, this system sees the need to increase or decrease the ozone in order to make for stable ozone concentration output. The last function I want to talk about is the local remote function right here. Up until this point, we've been controlling it locally with this automatic control device. We have the option of controlling it remotely using a PLC. If that's the case, we would simply switch this to remote, and now the PLC will take over control of the entire system, including managing the ozone concentration. The last component of our ozone control and monitoring system is the ozone sensor itself. The ozone sensor is mounted in what's called the flow cell. In the flow cell, we introduced the ozonated water that we intend to measure by way of this rotometer flow control. You can see as we rotate this, we can adjust the flow for a value that is recommended to be approximately 7 gallons per hour. As you can see, the sample for this cell is being taken at the exit point of this tank. It's important to know exactly what ozone concentration we have after all the mixing has been done and after the product is ready to be sent to the application.